In this problem, we're asked to find the volume of the solid that's bounded by the cone. That would be the blue cone in the figure below, and the hemisphere, which is the green shape in the figure below. And they also mention that that figure does not necessarily match these equations, but it is a representation of them. So I have drawn off the actual equations using Maple. So here is a graph of the blue cone and the green sphere. And we want to use spherical coordinates. So I've eliminated everything except for the region that we're interested in. And you can tell from this region some of the values that we want to be using in our integral. For example, any line that radiates from the origin inside of this figure is going to exit out the green sphere. So we know that the values of rho in spherical coordinates are going to be going from 0 to the radius of the sphere, which in this case is the 10. So we already know that the rho varies from constant to constant. Not only that, but we can also tell that this figure goes all the way around the circle in the xy plane, which means that our theta in spherical coordinates would be going from 0 to 2 pi. Now what remains is for us to find the value of phi. So in looking at our figure, we notice the z-axis runs right through the middle of our figure. The edge of the cone is the value of phi that we need to find. And so that will be a constant value for this figure. But we need to find it. So to find the value of phi, we're going to take the equation of the cone. So our equation of our cone was z equals the square root of 4x squared plus y squared. Now converting this, we will square both sides and have z squared equals 4 times x squared plus y squared. And the z squared in spherical coordinates would be a rho cosine phi. Now x squared plus y squared is the same thing as r squared, which happens to be a rho sine phi. And so from here we need to solve for phi. So we've got a rho squared cosine squared phi, and we've got a 4 times rho squared sine squared phi. So we'll divide both sides by rho squared sine squared phi. And the rho squareds will cancel. Cosine squared phi and sine squared phi, according to our trig identities, is a cotan squared phi. I don't particularly like dealing with cotans, although on a TI-89 you could do that just fine. So we'll write this as the 1 over tan squared phi. We'll do the square root of both sides and flip it over. So we'll get a tan phi equals 1/2. So then our phi would be the arctan of 1/2. Now, you can check that out on your TI calculator, but that is not a nice value. So we'll do that on our calculator. Now we know then that our phi is going to vary from 0 to that number. So we'll set up our triple integral. Now our integrating factor is going to be the rho squared sine phi. And since all of our limits are constants, it really doesn't matter what order we do these in. So we can do a d rho, where rho goes from 0 to 10. We could do a d phi, where the phi goes from 0 to that decimal value. And then we'll finish it out with the d theta from 0 to 2 pi. Now, I won't finish this integral. However, you can do this by hand, or you could enter it into the TI-89.